let us understand now how can these videos, how can these images be represented in a computer system. Images are basically composed of pixels where each pixel stores what is the color of that particular pixel. Many of these pixels put together form an image. So now these images, they are basically represented as a 2D function where there is some color that is getting stored at the x and the y axis, and the images get used in various purposes, like for multimedia and entertainment, for medical imaging, satellite imaging, computer vision, and AI. So these images, they enable the digital imaging processing enables analysis, enhancement, and interpretation of these data. Video is nothing but several of these images which are displayed over time. These are so fast that we think that it is a video which is running, but internally it is nothing but several images that are there. So each frame is a digital image, and so several of these images displayed across the time dimension represents the video. So under video we will have the concepts like how many frames are getting displayed per second. So usually if it is like 50 frames per second, it is good to the human eye, that is there is no hindrance that is visible to the human eye. If it is less than that, then there is some kind of hindrance, flicker seen visible to the human eye. Then there is resolution, compression, how can the video be compressed and stored. So for videos, we have various applications like video streaming platforms, surveillance systems, video conferencing, autonomous vehicles. So how are the images getting formed? The images are getting formed when consider if there is an image. Consider if there is an image, the light falls, falls on that particular object and it is getting reflected by the human eye. Because it is getting reflected, it reaches our eye, and then the visual cortex in our brain helps to create that particular image, which is then perceived by the brain. So this is how basically how a human eye perceives images. So images can be captured from the electromagnetic spectrum or the non-electromagnetic spectrum. See, images, what we are able to view is this particular under this particular bandwidth, which is the visible light. Only in this particular bandwidth we are able to perceive, that is only if the visible light is falling at this particular wavelength, only we will be able to see the images. Now see, x-rays are also getting formed. Now x-rays are formed by some other means. Then there are cosmic rays, even those help to form some other kind of images. Microwaves, radio frequency. So this is the electromagnetic spectrum. We human eye can see only a small portion, but there are different imaging systems like x-ray imaging systems and other systems which help to capture more information. So a digital image is a representation of a real world image. It's captured across x and y and there is a value. Now each value is given a value. If it's a grayscale image means white, shades of gray and black. Now the pixel values can range from 0 to 255, where 0 indicates black, 255 indicates white, and different colors in between indicate different shades of gray. A color image will have three components, R, G and B, where for each of the component R, G and B, the values will range from 0 to 255. So this is how the value, this is a small portion here which is getting represented using the pixels here like this. Each of the pixel here is this blue color small portion is getting represented like this, where each of the pixel is getting represented by one RGB color values. Now we are going to see what is sampling and quantization. Sampling basically refers to dividing the image into a grid of pixels. Now here, more the number of pixels, better is the image. If it is high sampling, it leads to more pixels, clearer image. If it is low sampling, it is fewer pixels, and it leads to blurry image. So consider this. This is 256 by 256. This is a more clearer image than this one, which is 64 by 64. Similarly for these as well. So this is high versus low pixel. This has lot of pixels, but this considerably has lower pixels. Quantization basically refers to giving the values to each of the pixel. So let's say if it's an 8-bit image, that is 256 intensity levels are possible, 0 to 255. If it's an RGB, then for each and every pixel, 3 values, one for R, one for G, and one for B will be there. So quantization is nothing but how many shades or colors will be there. So this is basically quantization. Now here, this is an 8-bit pixel where I have the values ranging from 0 to 255. This is a 4-bit pixel image. That is, each pixel will be represented using only 4 bits. So the 4 bits as in 2 to the power 4. So only 16 color representations are possible here. This image is a 2-bit image. 2-bit image means 4 values only: 0, 0, 0, 1, 1, 0, and 1, 1. So as you can see here, there are only 4 colors in this particular image. And the last one is a 1-bit pixel. So now in this 1 bit per pixel, here we are able to see only either a 0 or a 1. 1 bit, 2 to the power 1, and hence we are able to see only 2 colors, which is a 0 or a 1, and hence a black or a white. So image sampling basically refers to dividing the images into pixels, helps you determine the resolution, and quantization is basically giving the color values to each and every pixel, helps you determine the color depth.